Hi there, thanks for joining us. This is a Q&A edition of Space Nuts. It's where we take questions from the audience, we tear them up, throw them in the bin and just make up something else. Today, we are going to answer questions about things yet to be discovered. That'll be a short conversation. Finding planets closer to Earth versus distant discoveries. Somebody's a bit confused about that. We spoke about comets in the last episode. We're going to look at one specifically because we've got a question about Comet 2026A1, a very, very recent discovery. And remember when Rusty from Donnybrook so long ago suggested that we could cool the planet with a solar pergola? Well, he thinks Elon Musk has the answer, and he's going to ask us a question about it on this episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2,
3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Joining us again to try and sort all of that out is Professor Fred Watson, astronomer at large. I know he loses sleep over the audience questions because he just wants to get them all so right. Hello, Fred.
Hi, Andrew. Yeah, I do like to get them right. It's why people ask questions.
Sometimes we get challenged, or sometimes we have somebody look something up and say, I think you needed to tell us a bit more. But, we do our homework sometimes. We get back to people. Sometimes takes us a year or two, but we do it.
We're always aiming for adequacy.
Adequacy is key when we talk about Space Nuts. Shall we get into some questions, Fred?
Let's do that. I'm just going to turn the light on. Just hang on a moment.
Okay.
So I can see what I'm doing here.
All right. Well, I'll just sit here and peruse the question. There it is.
Here we are.
Okay.
I don't know whether that made any difference, but I can actually see what I'm doing now.
It helps.
Yes.
Let's start. Hi, Fred and Andrew. Do you think there are things in the universe that we haven't imagined existing? We didn't see exoplanets until the 1990s, but we assumed they were there and we were right. But what about things we haven't considered, like an undiscovered element or a planet bigger than its parent star? What else could be out there? That comes from South Africa, actually, Bailey in Durban. I visited Durban last year. It's a fascinating place. Beautiful beaches, lovely.
Mm.
On the western Indian Ocean, I think you'd say, yeah, the west coast of the Indian Ocean.
It is, that's right.
Or the east coast of Africa, whichever way.
Yeah, that's right. That's what I was struggling with.
I was doing the ocean side rather than the, Well, that's because I live over here and I was thinking in terms of where it is in proximity. Yes. It's on the western side of the Indian Ocean.
That's correct. But
sorry, Bailey, getting very confusing.
But it's a great question. And I mean, the answer is yes, really.
It has to be.
Even just within the last few months, we've got things that people have not considered before, little red dots.
Yes.
Galaxies in the early universe that look as though they're too massive for their age, their young age, because they're can't be more than a couple of 100 million years old, and yet they've got very high mass and are very concentrated, and that didn't really fit the theory. So these sorts of objects, especially as our telescopes get bigger, are going to take us by surprise. And I think, the James Webb Telescope has certainly done that par excellence. We've come across so many things that were unexpected and had to almost rewrite the textbooks in many cases. And the next big thing in that regard, as I've said many, many times before on Space Nuts, will be the ELT, the Extremely Large Telescope, with an aperture much bigger than the James Webb Telescope at 39 metres compared with the 6.5 metres of the Webb. So we're going to learn stuff from that will, I think, blow our minds. Could be exactly the kinds of things that, Bailey's mentioning, exoplanets bigger than their parent stars and things like that. An undiscovered element is less likely because we know kind of what's going on in the elemental world from the periodic table, which doesn't have any
Although
gaps.
the periodic table does purposely have gaps in it for future discovery, doesn't it?
Well, yes, but they're all at I think you're kind of beyond the elements that would exist in nature.
Right.
Because
so
of the
something
mass,
we might accidentally invent in the kitchen.
to make. Yes.
Yeah. I'll try to make
kitchen
sourdough.
nuclear reactor somewhere. if your sourdough, if your sourdough produces new elements, so I think you're probably burning it a bit.
Probably.
And you might need to watch for the radiation that's coming from it as well.
Yes, indeed. I've been just sort of doing some AI searches on things that
Good.
may one day discover. Gravitons, we've talked about gravitons several times.
Yes.
We don't know if they exist, but they might. We've never found one, but it seems to be a plausible way of, justifying the existence of gravity. New states of matter, just a generalization, new states of matter.
That's actually a good one, because there are subtleties in the states of matter that are still being discovered. That might be physics that does that, though, rather than astronomy.
Yeah, maybe. Black hole stars. There's another one people have often asked us questions about. They haven't actually found one, but they're starting to find evidence that could lead to the possibility of one. Is that a fair point?
That's right. Yep.
And the other one that comes up a lot, white holes, wormholes, cosmic strings, other dimensions, multiple universes.
In a sense, they're things that, if they were discovered, they wouldn't surprise us, because there's already a theoretical background for them. But the things that I guess that perhaps Bailey's thinking of are things like the little red dots, which we now know are very unusual aggregations of stars in the early universe, which we didn't think existed.
It might have been what prompted the question, because it's been big in the news lately, and I actually saw another story about it the other day. It's continuing to hold.
It is, that's right, yes. Yeah, we still don't really know what they are.
Yeah.
The latest theory is slowly spinning dark matter halos. Ooh. They are, I think, the latest theory for what actually makes these compact red galaxies that the Webb Telescope has been finding in the early universe. That's, I think, the current theory. That was October last year that I saw a paper on that. So yes, it's still a work in progress.
There you go, Bailey. There's still a lot yet to be discovered, and some of it will definitely surprise us down the track. Like even in the last episode, we were talking about a comet that reversed its spin.
Yep.
No one's ever seen that before.
Yeah. No, that's right.
So that's the sort of thing we're talking about. Great to hear from you. Hope all is well in Durban. They've got a great water park there too, by the way. To our next question, if we can find planets orbiting stars in other solar systems, hundreds or thousands of light years away, why can't we find Planet 9 in our own solar system? I believe that we're not even sure about how many planets are in the Alpha Centauri system, which is our closest neighbour. I don't understand how we can't find things close by when we can find things eons away. Please enlighten me. That's from Sarah in Townsville in North Queensland.
A great question too, Sarah. Thank you for asking that and sending it in. And it depends on the technology and the techniques that we're using to make these measurements. Planet 9 is a peculiarly difficult thing to try and observe because it's going to be faint. It's going to be, for all intents and purposes, just an ordinary star until you observe it over a fairly lengthy period of time when you might detect its movement. It's so far away, if it exists. Whereas, turning to Alpha Centauri, that's another good point. We do know that there are planets in the Alpha Centauri system, but there might be more than we think there are. And so
I think they've found gas giants at this point, but they believe there are probably rocky planets, but we haven't found them.
Yeah, that's right. And there's a couple of things going on here. One is that the smaller the planet going around a star, the harder it is to find it. And also it might take a lot longer to find it, because if you've got a planet like the Earth going around a star and you're looking for its signature on either the light or the velocity of the star, it's got this 365-year period. So it's something you need to observe over a long period of time. But the other thing I was going to say is that the two main methods for finding planets around other stars are, first of all, that what we call the Doppler wobble technique, the fact that as a planet goes around a star, the planet pulls the star slightly out of place, and you can actually measure that displacement of the star's light, because it turns out that you're looking for velocities in the region of a meter per second. That's a very low velocity for trying to measure these things by the radial velocity method, spectroscopy, the Doppler effect. So the Doppler wobble technique is really sensitive to massive planets that pull the star slightly off center more than a smaller planet would. And it's also sensitive to massive planets which are close to the star, because they have the biggest impact on the star. So you've got this combination. That means that you really need a lot of light to make these measurements. So for the Doppler wobble technique, you've got to have stars that are relatively nearby, i.e. they're relatively bright in our skies. But then you might find that we know much more about some systems that are further away, because you're measuring those by what we call the transit technique, where the light of the star dims slightly when the planet passes in front of it. And that actually is more sensitive. First of all, it's more sensitive to things further out in a solar system, further away from their parent star. It's sensitive to smaller objects as well, because we can measure brightness much more accurately than we can these tiny radial velocities, these tiny speeds along the line of sight.
There is a downside to that process, though, isn't it? The transit method, because I think to confirm an exoplanet, you've got to see it twice, is it? Or
yes, has to be. And if it's to be seen twice,
if it's orbiting a star at like once in 1,000 years, don't come back next week. Basically.
No, that's right. In fact, you really want to see it 3 times, because that way you know that it's the same period of the planet going around the star. You'd really like to see it 3 times, so that you can measure the distance between the first 2 transits and the second 2 transits, and they should be the same. Because you're looking at something in orbit around the star, but 2 is acceptable as well. And what I was going to say was you can look at that, you can make that measurement for objects much further away. Now the Alpha Centauri system doesn't lend itself to the transit technique, and so that's why we're not sure about how many planets there are. It doesn't lend itself to very lightweight rocky planets either. So it's a great question, and it's got some fairly sensible answers, and really they depend on our abilities to discover different things under different classifications of observing, for example.
Yeah, and it's an interesting quirk, isn't it, that the closer something is, the less likely we are to find it in certain circumstances. So,
under some circumstances, that's right, yeah. But mostly being nearer makes, generally speaking, something that's nearer is easier to make discoveries from, just because you've got more light to play with.
Yeah, fair enough. Thank you, Sarah. Lovely to hear from you. I've actually never been to Townsville, but I'm going to get there one day. I think the furthest north I've ever made it is, or if you don't count being on a cruise ship, is Whitsundays. About as far north as I've ever been able to get. This is Space Nuts with Andrew Dunkley and Professor Fred Watson.
I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth.
Space Nuts.
Last episode, Fred, we were talking about Comet P41, which was doing that weird re-spinning thingy it did. It stopped spinning one way and started spinning the other way, and very confusing. What we're talking about now is a question from Anchorage, Alaska. Woo! Eli has messaged us. I've heard that there has been yet another once-in-a-lifetime comet being discovered and will be visible in April. They're even saying we might be able to see this one in daylight. It's called C2026A1 and is referred to as a sungrazer. What makes this one so special? Where will it be visible? Thanks, Eli. Great question. I did read about this one. I meant to bring it up with you, but Eli's done it for me.
Yeah, that's nice when that happens. Well, it is a sungrazer, which means it, as its name implies, passes very close to the sun. Often sungrazers fall to pieces because the gravitational forces that they feel as they pass the sun, what we call the tidal effects, tend to want to pull them apart. And so sometimes they just disintegrate and you get lots of little comets that aren't really that interesting. Yes, Comet C2026A1, it will pass something like 160,000 kilometers from the sun's surface. And it may be that the way the light is being released from the comet, what we call forward scattering, it could make the comet look quite a lot brighter, which is one reason why people are talking about it being a daylight comet. I'm always very skeptical when people talk about that, because there's that old story, comets are like cats, they have tails and do anything they like.
Yes, I love that.
And yes, great. And it's perfectly true as well, that you never quite know what a comet is going to do. But some of these sungrazers have turned out to be quite bright. So it gets nearest the sun in April, and it's probably going to be one that is not that that won't give us that much time to observe it. And I'm saying that because it's got a long period of probably something like 6,000 years. Sorry, beg your pardon. No, not 6,000. About 800 years, something of that sort. And in fact, I've got a figure here that is double that. I'm probably looking at the wrong numbers there. Orbital period, something like, depends on what part of the orbit you look at, 1,687 years inbound. So yes, it is an object that's pretty interesting. I think if it gets bright and actually starts showing signs of being a very, very brightly visible planet, we'll talk about it again. But for the moment, I'm always skeptical, because you never know what a comet is going to do. And usually they don't do what you want them to do. So, like cats. Just like cats, yes. Remind us again how they name them, because I'm gathering from C2026A1, this is the first one they've spotted this year? It's also got a temporary designation, 6AC4721, which I think is probably the designation for the object category when it was actually discovered. But you're right. Now, the P prefix on a comet is when it's periodic, and that usually means it's got a period of less than 200 years. This is not a P, this is a C, and it tells you that its sort of classification is, I can't remember what C stands for, actually. I know. It means we're all cactus next time it turns up. That'll be it. Yeah, that'll be it. I think you're right there. Yeah, just takes a long, long time to come back and say hello. Yeah, it may be, it's sometimes called a Kreutz group comet, but that would make it a K rather than a C, so that can't be what it is. No. I could try and look it up. But, why don't you do that? Yeah, all right. Why don't I? What does the C stand for? I've got to type fast.
in the naming of a comet?
Yep, that's the right question.
That's an AI
I
question.
will say stands for cactus.
Cactus. No, it says, you're not going to believe this, C stands for non-periodic.
Yeah, that was what I thought, but I couldn't work out where the P. Maybe you take the last letter of the word, non-periodic.
Yeah.
On the other hand, if you did that, a periodic comet would also be a C. So we're not getting any nearer.
Well, see, they've painted themselves into a corner, haven't they?
Yeah, absolutely, yeah. So much for the International Astronomical Union.
Yep. That's what happens when you put bureaucrats in charge. No, they're good people. So it may
Look out for it.
Yeah, look out for it. It may be good to observe. Whether or not it's a visible comet in daylight, debatable. But it's definitely on its way. And April is the month to keep an eye out for it. Where would be the best place to sit to have a look at it?
Somewhere dark.
Anywhere on the planet?
I don't know. I don't know what the exact details of its orbit are. So it may well be one that is best seen before dawn or after sunset, but it would depend a little bit on what your latitude and longitude are.
Okay, best places, best regions, mid-southern latitudes, Chile, South Africa, Australia and New Zealand. Well, I think the best opportunities. There you are.
Thanks. So, yeah, I think we should just stop Space Nuts and go to AI.
No, they've got funny voices. No.
Yeah.
I don't think so.
We've got funny voices as well.
And their jokes are terrible. Oh, hang on, that's the same. Oh, dear. All right. Eli, thanks for the question and hope all is well in Anchorage. A very interesting, remote, cold place, but much visited. Lots of tourists go there for obvious reasons. It's just such a unique destination. Thanks, Eli.
I'm going to step off the limb now. That's one small step for man, one giant leap for mankind.
Space Nuts.
Our final question comes from a regular. I don't like to give him too many bites of the cherry, but he's just come up with something that I could not avoid based on previous theories that he's come up with. Rusty from Donnybrook. He says, Elon's 1 million satellite power station. Hi, Fred and Andrew. Just looking at the environmental impacts of these power stations, about a quarter of these will shade the Earth at any one time. Each will have about an acre, 4,000 square metres of solar collectors. I don't know what the next bit means. The ISS is 2,500 square metres.
That's right.
He will use about 20% efficient cells and there will be about 10% loss in conversion of light energy. If the undersides are black for astronomical purposes, then we have an 800 square kilometre array of solar for our solar pergola. Elon will kill two birds with 1 million stones. Data centre power and global warming. I caution that if he doubles the size, it will create a cooler environment than we want. Cheers, Rusty from Donnybrook. He won't give up on his solar pergola. He came up with the idea, I don't know, a couple of years ago and pitched it, and we basically kiboshed it. But now, could Elon have accidentally created one?
I don't know. I checked what's available about the spacecraft design for these proposed 1 million satellites that that SpaceX is proposing to act as an orbiting data center. Mm-hmm. And I couldn't find any dimensions for the solar panels. An acre or 4,000 square meters sounds very big to me, and a large amount of real estate that I am not sure is. I suspect Rusty's not Donny of Rusty Brook, but Rusty of Donnybrook.
I like that.
Rusty might have done the calculations as to what's needed, but so far I haven't seen any details of the individual spacecraft. In fact, they may not exist. But an acre for each one sounds like a lot of real estate for 1 million satellites. And I suspect it's not going to be anything like as big as that. So I think the solar pergola idea will once again be shelved, as it has done many times before.
Maybe. Based on recent reports regarding SpaceX's proposed orbital data center plans, the solar panel infrastructure of these satellites is projected to be massive, with some proposed structures stretching to 4 by 4 kilometres in size.
Well, if you do that, you're kind of, it marks the end of astronomy, really.
Yeah, it can't be right.
4 by 4 kilometres. Yeah.
Maybe not all of them, but some of them, it says.
Yeah. Interesting. I don't even know that we have the wherewithal to manufacture solar collectors of that sort of size.
Yeah, I think.
You'd
have more like putting a pie in the sky, I reckon.
The current state of that venture is that it's gone to the Federal Communications Commission, and I will be interested to see whether they approve it, because eventually it's got to go to the International Telecommunications Union, and they will probably freak out a bit, because they are, whilst they are kind of mandated to issue launch permits to anybody who can demonstrate the likelihood of being able to put their spacecraft into orbit, I think this one might actually cause them to swallow a little bit deeply. Although they did tick off on the 300,000 spacecraft of the Rwandan government's proposal back in 2020. I think that will lapse next year. I think it's a 7-year period that you've got. When you put in a filing to the International Telecommunications Union, I think you've got 7 years. And if you don't launch anything before that, then you basically lose the slot.
Yes, I believe so. And it may well be that that's what's going to happen in this case, although Elon tends to have, the cash to back his ideas, and he certainly followed through on a lot of them, and they've been very, very successful. So,
that's right.
One wonders where this will end up. But are they really going to approve that kind of infrastructure in orbit if it's going to cause so many problems for so many other people, especially space science?
The first, yes, that's a good question. We kind of hope that common sense prevails. Another of the problems, of course, and this is already being noticed by Starlink, it's more or less one Starlink spacecraft a day that now re-enters, because they only have a 5-year lifetime. And we're already starting to see pollutants in the upper atmosphere that come from these spacecraft burning up. Now, I was in a meeting last week that I heard one of my colleagues, it was a meeting actually in Vienna, and I was just dialing into it, but one of my colleagues who's based in the UK had a throwaway line, which was that Musk is going to put the defunct data center spacecraft into a solar system orbit rather than basically bring them back into the Earth's atmosphere to avoid that problem. But I don't know whether that's true. I haven't found any references to that online. And it would mean, to do that, you need effectively an awful lot of rocket power on each spacecraft, because it takes much more oomph to get rid of a spacecraft that way, to put it into orbit around the sun, than it does to put it back into the Earth's atmosphere. So all of these are questions that I think will be raised by anybody who's really interested in this stuff, and that includes space nuts.
Yes, well, Rusty at least.
And Rusty. Well, Rusty's a space nut.
He certainly is, yes. Good question, though. Love it. Keep working on it, Rusty. I'm sure you'll come up with another solar pergola theory in the not-too-distant future. Good to hear from you, and good to hear from everybody who sent us in questions. If you've got questions for us, we'd love to get them. Just go to our website, spacenutspodcast.com, spacenuts.io, click on the AMA button at the top, the link that says Ask Me Anything, basically. And that's what you do. And don't forget to tell us who you are or where you're from. Text and audio questions, most welcome. And have a look around while you're there. And don't forget to visit our social media pages as well. Fred, we're done. Thank you very much.
It's a pleasure, Andrew. It's always good to be done. And sometimes it's good to be undone as well.
Yes. Well, that's, getting a bit too personal. But anyway, we'll carry on. Thanks, Fred. We'll see you later.
See you next time.
Professor Fred Watson, astronomer at large. And thanks to Hugh in the studio, who couldn't be with us today. He was looking into Bailey's question about things that are yet to be discovered, and he realised that nobody knew he existed. From me, Andrew Dunkley, thanks for your company. We'll see you on the next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.